Welcome to this video on a mobile app test strategy. I asked you what video I should make next, and you voted this video. So here we are. I'm going to go over my current team's mobile app test strategy approach, some gaps in our approach, and how we plan on fixing those gaps over the next year or two. There's going to be 4 parts of this strategy, and you're more than welcome to skip ahead to any section that interests you. We're going to go through how design, build, shipping, and support incorporates our testing feedback loops. So first of all, to give you a bit of context, the way our team works, we have an Android developer, an iOS developer, 2 backend developers, 2 business analysts, 2 testers, a designer, project manager, product manager as well. And we have a bunch of other people who help support the team throughout the cycle. We work on a 2 weekly sprint cycle. We use a flavor of Scrum Agile. We are part of one of the big 4 banks, but we're part of a business that's being sold off in a few months' time. That does introduce some complexities. Working in a large corporate structure does come with bureaucracy and a lot of like, for example, just trying to set up some of our CI/CD pipelines has involved a fairly bureaucratic process. You have to raise requests, and it can be hard to coordinate or to get things to work the way you want them to. So there are elements of this test strategy that have recommendations in place for when we are sold off, when we demerge from one of these banks, that then we can control more of our CI/CD pipeline, and we should have more flexibility with how we incorporate elements of that into our test approach. We currently release our backend on a monthly cadence, and we use tools such as Jira and Confluence to help document our process. So I'm going to go over 4 parts in this video: design, build, ship, and support. And we're going to go through each one in a bit more detail. You can consider all of these elements as feedback loops that create our overall test strategy. Hopefully with enough feedback loops in place, we mitigate major bugs getting into production. The idea that these feedback loops also feed into each other and that the whole team is responsible for testing helps enforce our overall strategy. And it's not just one person's job on the team to look at quality for the mobile app. So how does design feed into testing? We collaborate with the designers and UX researchers on our team. We were recently doing some user research and getting involved, or at least sitting in on some of the interviews, because one of the features we're looking to build in our app soon is notifications. And this is a fairly common feature across many mobile apps, but it was in the context of this particular app, and it was like, do we build in a message inbox type of thing in the app, or what type of notifications do people care about? So the user researchers were testing different ideas around how notifications could work with about 5 or 6 potential users. If you're doing a UX research group, you generally only need about 5 or 6 people, and that will help you get most of the errors before you even build something incorrectly. It would be a huge waste of engineering effort to go through all of that development and then realize you built the wrong thing. So that's how we test early and often, if we're building the right thing and getting the right feedback as well. Also, when designers are coming up with new features, we're often involved with the planning sessions to help raise concerns either about accessibility or how hard it might be to build from a dev point of view. And so the developers have also enjoyed being involved with that process so that they can raise their feedback early on. And we're constantly incorporating user feedback and bugs and enhancements from having the app on the app stores for the last year, and seeking in-app feedback every time we release a big feature. So we've incorporated lots of feedback loops into getting the app to where it currently is right now. And we're constantly iterating and testing new designs for future enhancements as well. We also collaborate on the acceptance criteria that we create for every story. I'm not going to go into too much more in design. It's not necessarily the scope of this presentation. So I'm going to next go into how we build and incorporate quality along that process. So we have devs and testers who work side by side in the team. The developers are usually responsible for writing some unit tests, building the features. We often help out with the code reviews, potentially writing UI tests or doing more exploratory testing for each feature, or owning our end-to-end testing framework. But we have a very collaborative approach, and everyone tends to help in with each other's tasks as well. We have a continuous testing pipeline set up. All of our unit tests will get run on every pull request, and then once they're green and the code has been reviewed, they're being able to then merge into the development branch, and our unit tests will run against that branch again. And once it's been merged into dev and those tests pass again, we automatically release test builds to App Center so that it doesn't take that much time for when a pull request is created to when it's merged into a test build, so that's available for anyone on the team to test new features. However, if you're involved with the dev process, you're more than welcome to test earlier on in the process. You could check out the pull request manually and do a whole bunch of stuff to help the testing process through being involved and collaborating with engineers. We use Git in there's a slightly more process around how we use Git. We use a local fork. We do code changes locally. Then if we're wanting to submit those code changes, we'll create a branch, we'll commit the code against that branch, and then create a pull request from the local fork back into dev. And then once it's been reviewed, then it's only merged into dev. And I'll do a follow-up tutorial on some of the Git commands that I found useful later on. In this presentation, there are a lot of things that I could dive deeper into from a technical point of view, but I'm going to do those as follow-up presentations to give you more of a deep dive. But this is just a brief overview. For iOS, we have over 800 unit tests. We use XCTest. Nearly every new feature that's built has got some unit tests that are built by the developer. They run on every pull request and every merge into dev. And if you wanted to run them locally, we use a command bundle exec fastlane test. We also use snapshot tests, or screenshot tests I should say, for our iOS repository. There's a lot more resources online for how to incorporate screenshot tests into your app. And I found screenshot tests to be great for doing code reviews because when they are submitted as part of the code review, so you can see what's changed in the UI as part of the pull request process. It's actually pretty cool. We don't quite have screenshot tests in our Android repository just yet, and that's a potential gap we'd like to fix further on down the line. We have over 700 unit tests in our Android repository. They're built using Espresso, and they use a robots pattern so that the test is fairly simple and straightforward to read. You have all of the structure code of all the app UI elements. You create a robot for each screen, and that can control the elements and the interactions. It's very similar to a page object model architecture where you're using, you're trying to abstract away all of the UI elements such that your unit tests are more structured. Again, these run on every PR and when they're merged into dev, and there's a couple of commands here that we use for running different layers of different tests. We also have a lint format checker as well set up for our repository. Whoops. We do have some UI tests for Android, but they are generally a little bit flakier. And one of the problems we have is we're using TeamCity at the moment, and we can't install extra Android simulators on those build agents. It's been a struggle to try and get that to work. And the only emulator we have as part of our CI/CD pipeline is an Android 6. And our our UI tests are extremely flaky on older Android operating systems. Google have enhanced a lot of their Android testing frameworks since older Android versions, but we need to consistently be able to get our UI test to pass on a later Android operating system before we can incorporate these UI tests as part of our CI/CD pipeline. So one of the things we want to do short term is reduce the flakiness of these tests, but we'll commit to running these locally whenever we have whenever we're working on a change that changes the UI. That's just that summary there. So yeah, we're currently using TeamCity. We have some problems with that, and we'd like to, once we've got more control over our own CI/CD pipeline, we can expand these UI tests a lot further. So we're thinking about using GitHub CI/CD when we do demerger. And we could do things like incorporating accessibility testing with large font, incorporating screenshot testing, and incorporating some sort of cloud-based device testing farm as well. For iOS, we use the simulators to generally test most features. We'll always test on a real device, but I like to use a variety of simulators when I'm testing. So usually my heuristic for mobile app testing is usually testing on the smaller screen, testing on a medium screen, and testing on the larger screen. So I generally always test on an iPad. And I find the iOS simulators are generally pretty good, and we haven't found any device-specific bugs that weren't reproducible on a simulator. I think that's how good these simulators are now. I know back in earlier mobile app development, the simulators weren't always all that accurate, or there were specific bugs that were only simulator but didn't impact real devices. Actually, we do have one of those bugs at the moment. It's with our terms and conditions page, but it doesn't impact a real device. So it's not a bug that we're necessarily going to fix at the moment. But yeah, we use a variety of devices when we're testing. And I have the same approach when I'm doing Android. I have all of these different emulators set up for all of our Android supported versions. I've got a mixture of screen sizes, and since I've taken this screenshot, I've also added a tablet into my emulators. I find the emulators for Android aren't as great as the iOS ones, but I think it's also because other providers out there put their own spin on the Android operating system. So Samsung like to customize the Android experience, and so what works on an Android vanilla emulator might not necessarily work on a Samsung device. I have found that the Android emulators have gotten a lot better over time. I've been doing mobile app testing for about 5 or 6 years, and I've seen huge leaps and bounds in testing tools for both developers and testers that have made it a lot easier to test on a dev machine. We have a mocking framework built into our mobile app. So with our test builds, we've got these debug options, and you can select the app version and set up a mocking profile. So if you want to see what our app looks like for an investor versus a pensioner, or all the different account varieties that we can support, you can go into the debug options and select the profile you want to do. I do plan on doing a deep dive into how to build a mocking framework into mobile apps in the future, so keep posted for that if you want to learn more about how mocking frameworks for apps work. As testers, we maintain both the Android and iOS mocks to be up to date. Most of my pull requests raised into our GitHub repositories are to maintain our mocking framework. This has been a really cool testing thing that we've built. We're able to test our mobile app completely independently of any test environment. And if we're doing this, is a great aid for exploratory testing as well. So instead of trying to find data where you've got like a really long transaction name to see if it line wraps, you can just modify the mocks locally, build it on an emulator or simulator, and then see if the UI wraps or not. And even the business has been using these mocking frameworks to either help support the app or for even advertising and marketing purposes too. So it's been a great tool that we've built, and I do want to dive deeper into it in a later video. So we also have a minimum accessibility standard for our mobile apps. Every new feature that we build has to support large font, has to work with the screen reader, and general color contrast standards has to be met. I often jump on my high horse and rant on about accessibility testing. Accessibility doesn't have to be hard for mobile, as long as you're aware of these two things. You've got pretty good accessibility already out of the box. It doesn't have to be a perfect experience either. We have still lots of bugs around accessibility in our backlog because we haven't optimized those experiences. But if you incorporate developers and designers into accessibility, it's a lot easier to get everyone up to speed with it. And I have some further resources that you can read into if you're interested in learning more about accessibility testing. We also help out with unit testing on the back end. We will tend to collaborate with the back-end developers to come up with effective unit test strategies. We'll assist each other in code reviews, and we have contract testing for APIs that are downstream of the mobile app. If one API is talking to another API, there's often a contract in place to go, hey, when I hit you, I expect JSON in this format. And then so the next time that provider of that contract runs, it executes that contract against itself and goes, yes, everything's all passed. If you're interested in learning more about API testing and contract testing, I'll have a link at the end of this presentation where you can read more. But also I do plan on doing a bit more of a deep dive into this at some point too, because it's a pretty cool framework to work with. It's called PACT, P-A-C-T, Provider and Consumer Testing, or Contract Testing. We do a bunch of exploratory testing for each new feature, and we don't necessarily test every feature on every supported device. We use a risk-based heuristic to gauge how in-depth we want to take our testing process. Also, if the feature calls the back end and it's complex and it's the whole tech stack, we'll often invest more testing effort and keep track of stuff that way. And so I'm going to go through a risk-based process in the next slide, and that'll reference these star ratings. So if it's a 1-star rating, it's relatively low risk. We might just test it on a real device just to check that it all hangs together. If it's a 2-star feature, we'll probably test on the smallest, largest, and on a real device. And a 3-star feature we'll test on every supported operating system and screen size. So for example, if we have these features in our app and we map on the x-axis frequency of use, and y-axis we've got impact if broken, and we can map out all of our features. So for example, return login is probably one of the most frequently used features and has the highest impact. If that's broken, a customer can't log in or a user can't log in, and we've got some big issues. And impact if broken is from the customer's point of view. There's so many different elements of risk, and you can map out a whole bunch of different ways of risk. So for example, this map doesn't take into consideration complexity, it doesn't take into consideration security or any other like privacy or legal. There's a whole bunch of elements of risk that aren't incorporated with this one. But so there's return login is a 3-star feature, and when we're making enhancements to any of those flows, we want to do really in-depth exploratory testing, whereas contact us might be not used as frequently and has a pretty low impact because the customer is able to potentially find our mobile number on a website or something, so there's a potential workaround. So for that one, we might not investigate as much exploratory or as much automation testing either. So when and why do we use testing notes? We use testing notes when we have an API and mobile changes. And it's when we want to document our testing process so that later on we can always repeat what we did. I found using testing notes to be very lightweight, but also really useful for 6 months down the track when we've refactored an API and we need to retest some of the new features. I'll often document the test case, the test accounts that I've used, maybe compare some Android and iOS screenshots side by side, because that's a really useful heuristic as a mobile app tester. If you're on a team that's developing both Android and iOS apps, having the two apps side by side can help you find discrepancies between them. Yeah, and they're useful for doing regression testing later on, or we've actually found using testing notes to be really useful for supporting our mocks. Often when our APIs get developed ahead of our mobile apps, and when we've done API testing and we've got really good testing notes, the developers will actually use those testing notes to influence their unit testing, and they'll take the JSON payloads from those testing notes to figure out how they do unit testing too. And this is an example of what my testing notes would look like. It would be a Confluence page, and I'd probably document the APIs that were part of the new feature, any SQL queries that were used to help find data for this feature as well, the account numbers that were used, iOS, Android screenshots, the sample JSON responses from the API when I tested it, potentially a web screenshot to compare across all three platforms, and maybe a database extract or response from the database if I wanted it all documented in one place. This is just really lightweight. It's just a simple table. It's on Confluence, and we have a repository on Confluence of all of our testing notes over the last year and a half, and it's been really useful for just whenever someone's like, hey, we need to retest something in that test environment pretty quickly. I'm like, hey, I got these test accounts that I can reuse. So that's how we go about building the app. Next, I'm going to go through shipping. We have an end-to-end testing framework that we use to support the app. It's very lightweight, it's also very happy path as well. And the main question we're trying to answer with our end-to-end testing framework is, can every supported app version talk to every API? We have an API for our minimum supported app version, and that sits at some version, but we release our mobile app monthly, so we could have 5 or 6 different iOS or Android versions of the mobile app out there in production that's hitting our current APIs. So we want to check that they can still talk to the current in-dev API before we release our backend API into production. And we generally only run this during UAT sign off, usually once a month, when there's that little bit of time in between finishing UAT and before we go into production. We built this using Appium and C#. We did originally have this framework written in Java, but we don't have any Java developers on our team. We only have C# backend developers, and no one else on the team wanted to touch this code repository with a 10-foot pole. When you have test code that sits outside of your production code, you're less likely to get collaboration with the developers on your team. I much prefer having as much test code alongside production code as much as possible, because then you can share that responsibility of maintaining that test code with developers as well. But if you do have to have an external test repository, having it in a language where there's more people on the team who feel comfortable in collaborating with that framework, I think is really useful. With our end-to-end testing, we do want to make some enhancements to it. With our current TeamCity approach, it's been really hard to get some of these enhancements in. So when we have our own GitHub CI/CD pipeline, we'll be able to run more continuously, but we'll also maintain these scripts when we add new APIs as well. We have contract testing in place for downstream backend APIs, but we don't have any contract testing between our mobile and our mobile APIs, simply because of the TeamCity constraints as well. We haven't been able to get a packed broker as part of our CI/CD pipeline, and with contract testing, the idea is that your consumer writes its contract, publishes it to the broker, and the next time the provider builds, it'll pull down that contract, run it against itself, and then publish a pass result. But because we haven't been able to add a packed broker to our CI/CD pipeline, it means we've got this gap where we haven't been able to implement contract testing between mobile and mobile API. When we do get to this point of having more control over our GitHub, over our CI/CD, we'd have to create a little library wrapper to be able to publish contracts to the broker in both Kotlin and Swift, and then we can incorporate contract testing and versioning for mobile contracts as well. And once we have this in place, we wouldn't need our end-to-end framework utilized as much. It still might be nice to have just as a last-minute sanity check, but with contract testing in place, the idea being you don't need as much end-to-end testing. But yeah, we're not there yet. We run bug bashes every 3 to 6 months, depending on recent changes. So I'll create a Confluence page with a couple of test accounts and potentially some links to devices that people can use, a heuristic of what's changed recently so people can focus on those efforts. And we try to give awards and shout outs to people who are our best bug hunters. In a previous team, I had this trophy of a bug, and I handed it to the #1 bug hunter to sit on their desk until the next time we ran a bug bash. So it's just an idea to have a bit of fun, get the team together, tools down, and try to find as many bugs as possible. And it's just to encourage that quality is a team responsibility. And to have a bit of fun around testing. Like, how often do you get to have a bit of fun with testing? When we come to releasing our software, we engage pen testing on a needs-be basis. There's a team within the bank that can help out with more specific mobile pen testing skills. And we generally only use them when we're making security enhancements. We often go through production verification testing once we've done the release on the weekend as a team, and we have someone else involved who runs performance testing before each release and compares it as a baseline to the previous month's release as well, to make sure that our APIs are still at least not degrading, they're still performant. So that's shipping. Now let's go into supporting the app. For iOS, we no longer support iOS 12. Once iOS 15 is released, we'll look at dropping support for iOS 12. It'd be nice if we could also drop support for iOS 13 at that time too, because any device that runs iOS 13 can actually support iOS 14. It's just these people haven't upgraded yet. And there are some cool elements with iOS 14. So SwiftUI has gone through a couple of enhancements for iOS. When it was released with iOS 13, it was still very minimal. But if you can use the version that was released with iOS 14, there's a lot more enhancements, it's a lot more fleshed out, and it would just be easier to build new features, potentially using SwiftUI. If we only had to support iOS 14. But hey, I don't know if we're there yet. We have a mixture of Apple devices that are used in the wild. We have 2 people using iPods. We don't test on iPods, but we do have users using iPods. It's actually surprising to see that 10% of our Apple users are on iPads, and that's helped enhance or drive a lot of we've gotten a lot of feedback for supporting iPad, and we're in the process of trying to figure out how to support landscape mode. We enabled portrait mode on iPad, and it looks like we're going to try to support landscape mode at some point as well, which is just really, it's just interesting to see some of these stats. So for iOS testing, we'll always test on a physical device. Most features will get tested on a tablet, and the simulator is totally fine. And we'll use a variety of simulators when testing, and if it's a really important 3-star feature, we'll test on every supported operating system. Android, we have a very similar story. The Android operating system uptake is a lot slower than iOS, and that's just because of the distribution of Android operating systems. Our top 10 devices for Android are all Samsung, so that's why we always make sure that we test on a Samsung device. So yes, always test on a Samsung. We will test out most features on a tablet, and the emulator is fine, and we use a variety of devices when we're testing. So, Android crashes. Android is not as stable as iOS, unfortunately, and you do get these issues where you get spikes and crashes for some features. If they don't impact every user or impact a high rate of users, they can be really hard to debug. And we've got this idea of, once we've got more control over our CI/CD pipeline, we can incorporate a chaos crash testing as part of our pipeline. The idea is we would use a UI exerciser that's part of the Android tools to randomly click and tap and do whatever it wants on the UI. It's a great way for finding crashes. And the idea being, we could just run that on a device or emulator overnight, and if we had a pipeline it's set up, the next night we could just run on a different Android operating system or different device, so that potentially over a sprint we could have 10 to 14 different devices that have had 3 to 4 hours worth of crash testing on every platform. And hopefully by building that, we'd be able to be a little bit more proactive with how we try to debug some of these crashes. So this UI exerciser will give you a seed if it does discover a crash, and the idea being that if you give this exerciser the same seed, it'll follow the same random UI elements in the same order, and you might be able to get to the same crash again, or you might not. It's like Android is just a little bit flakier, and it's only because Android can run on anything. It can run on your TV, it can run on your toaster, it can run on your phone, whereas Apple's just got more control over what its operating system can run on, and it controls the hardware, so Apple can only run on Apple stuff. So yeah, so that's just talking over the Android crashes and how we could be more proactive and encourage that, be a bit more proactive with our crash testing for Android. We don't need to do the same thing for iOS because we get less crashes. We've had one crash over the last 30 days on iOS, so we don't have the same issues. For metrics and monitoring, we actively monitor for crashes, we try to investigate issues in a timely manner, and we also monitor the app stores for any negative feedback or any potential bugs that we may have missed during our whole entire process. So there we go. Hopefully you can see that our strategy is like a big giant feedback loop. It's like a mesh. Every little layer is like a little net, and hopefully with enough of this crossover, no major bugs get through to our customers, that we get to get the feedback at the right time to make sure these issues are addressed. We also have this timeline of actions that I've put together. So before we demerger, we can do a couple of enhancements, like get our end-to-end tests into TeamCity. We can reduce the flakiness of our UI tests. After that point, we could start investigating using cloud-based devices for testing. And once we have control of our own CI/CD, we can then do contract testing for the mobile and backend, investigate a chaos crash testing pipeline for Android. We could incorporate accessibility testing and add screenshot tests to Android as well. It'll be a lot easier to do some of that stuff when we've got more control over our own CI/CD. So thank you. quality is a team responsibility. I hope you enjoyed this strategy and this walkthrough. And I have a big list of further reading if you're interested in reading any more. And I'm going to do deep dive technical workshops on a lot of the stuff that I've talked about today, just in further videos. And I'll share these slides when I post this up online too. So thank you.